Today we're going to add and subtract vectors. First we need to review what a vector actually is. So this is a line segment. A vector is related to a line segment, but it has an added dimension, a couple of added dimensions that a line segment doesn't have. So a vector has a direction. So this vector here may be the same length, line segment here, but these two vectors are not equal to each other. They are different. They may have the same length, they may even have the same slope, but because they go in different directions, they are different. This is also different from this vector, again, because they have different direction, even though they have the same length. This vector, okay, is going in the same direction as this vector, but again, these two vectors are not the same vector because this one is longer than this one, and we call that a magnitude. So the magnitude here is greater than the magnitude of this vector here. Now for a little notation. So I can call a vector by any letter I want, and we draw a little arrow above the variable to show that it is a vector and not a line segment or something that has no direction. The magnitude of the vector, so the magnitude of vector A, for example, would be written like this. It looks like that's a value. That is the magnitude of vector A. Okay, so now we can move on to the concept of adding vectors. So the sum of two vectors A and B is found by putting the tail, this is the tail, sorry, of a vector, and this is called the head. So if I'm going to add vector A and vector B, I'm going to put the tail of vector B right on the head of vector A. And this is what I mean. If vector A is here and vector B is here, and I want to find the sum, the sum of A and B, then I'm going to take this vector B, I'm going to take the tail of that, and I'm going to connect it to vector A. So vector A is right here, and vector B is, the tail of vector B is now on the head of vector A. Now you may ask, well, how can you just move a vector to another location? Is that changing the vector? No. A vector has a specific direction and a specific magnitude. But one thing a vector does not have is a specific location. So that gives me the freedom to move this vector anywhere I want. I can draw a copy of B 50 times all over the paper. Every single one of these is a clone of the original vector B, therefore these are all equal to each other. The only thing that distinguishes a vector from another vector is its direction and magnitude. Location does not change it. So I am able to move this vector so that its tail is on the head of this vector, and after I do that, the sum of a plus b is a new vector from the tail of a to the head of b. This is vector a plus b. And the magnitude of that vector is written as such. So this is the magnitude of vector A plus vector B. Alright, so now we're going to actually do a problem here where we are given two vectors, and we're going to find the magnitude and direction of the sum of the two vectors. Okay, so we have vector A, and its magnitude is 5, and we have vector B, its magnitude is 9, and the angle between them is 53 degrees. And we are going to find the magnitude of the sum of those two vectors. And we're also going to find the angle between the new vector, a plus b, and vector A. Okay, so I'm going to draw vector A, and that has a magnitude of 5, and now I'm going to draw a vector B, which has a magnitude of 9, so it's got to look about twice as much as A. It looks like twice as much. And the angle between them, meaning the angle where the tails meet, is 53 degrees. So this is the given information. Now, if I'm looking for the sum of A and B, that means I have to put the tail of B on the head of A. So this B, where I drew it, is in the wrong place. I got to shift it up. So I'm going to move this vector so that it's over here. So I'm going to redraw A. Just pretend that's the same length as this one. And I'm going to now copy vector B up here. Okay, so that's B. I'll draw a dotted line so you can see where B used to be. Okay, that's where B used to be. Okay, now I'm going to draw the sum of A and B, which is going to be from the tail of A to the head of B. So this is the vector that is the actual sum of A and B. And I'm going to draw a dotted line here so that you can see that this kind of creates a parallelogram. Okay, there's something else I know about this triangle that is formed by A, B, and A plus B, and that is this angle here. This angle here is 127 degrees, and that is because if you remember back here, this was 53. That's this angle right here. This angle was 53, and in parallelograms, consecutive angles are supplementary. So that's how I know this is 127. The 127 is important because right now I know the magnitude of this side of the triangle, that's 5, this side of the triangle, that's 9, and the angle in between, 127 degrees. So that means I can use law of cosines to solve for this side of the triangle. Alright, so let me label this as 5, 9. So law of cosines tells me the square of this side squared is this side squared plus this side squared minus 2 times this side times this side, 2 times 5 times 9, times the cosine of this angle, 127. Okay, so that's 106 minus 90 cosine 127, and that's going to get me to 160.13, and that's the square of that. So a plus b will be the square root of that, which is, and you would have to use a calculator for this part, 12.655, etc. So that is the magnitude, or the length of this vector. Okay, now the other thing, so I found that. So the other thing I need to find is the angle between a plus b and a. That would be this angle here. Okay, it's also part of this triangle. So I can find that using law of cosines now that I know all 3 sides of the triangle. So again, law of cosines tells me that the side opposite the angle, which would be this side, 9 squared, is this side plus this side, which I just found, minus 2 times 5 times 12.655, etc. And if you were using calculator, you would have this stored on your calculator so that you have the entire number and not a rounded version of the entire number. Times cosine of this angle, I'll just call this angle beta, so cosine of beta. And after doing all that arithmetic with the help of a calculator, you will get that cosine of beta is 0.823, etc. And you would again use your calculator to inverse cosine that and get that the angle beta is 34.607 degrees. So the angle here is 36.07, the angle that's here between a plus b and the original a. Okay, now we're going to find a minus b. So we're now using the same 2 starting vectors. We're going to find the magnitude of a minus b and also the angle between a minus b and a. Okay, so first of all, what does it mean to subtract vectors? Well, if you are going to do a minus b, that's the same thing as a plus negative b. So you're doing addition. So then the next question is, well, what does it mean to have a negative vector? Well, that's pretty simple. If you have a vector, say b, like this, negative b is simply a vector of the same magnitude pointing 180 degrees in the other direction. So this would be negative b. So if I'm subtracting b from a, all I have to do is draw the vector that is pointing in the opposite direction that b is, and then that will be negative b, and then add that to a. So here's my original a, which has a magnitude of 5. Here's my original b, which has a magnitude of 9. So I'm going to draw a again here, and then I'm going to copy the opposite of b and put the tail of it on the head of a. So that would be right there. So this is a, this is b. And now, sorry, that's not b, that's negative b. That's negative b, because it's pointing in the opposite direction. So now I have a plus negative b, which is a minus b, so that's what I want. And then I connect the tail of a to the head of b, and this is a minus b. Okay, so let's label some magnitudes here. So this is 5, this is 9. I'm going to find that in a second. Now, if you recall, b, the original b, was over here. And since negative b is b just in the other direction, this is parallel to this. Or I can say negative b is parallel to the original b. So if they're parallel, that means this angle and this angle are alternate interior angles, and they're congruent. And if you recall, they gave us this as 53 degrees. Therefore, this has to be 53 degrees. So again, I have two sides and an angle. So I can use law of cosines again to solve for the resultant vector. So I'm going to do that on another sheet of paper right next to this. Okay. So that side squared will be 5 squared plus 9 squared minus 2 times 5 times 9 times cosine of 53 degrees this time. And that's going to turn out to be 51.836, etc. We take the square root of that, and the magnitude of a minus b is 7.199, etc. Okay, so this is 7.199. Now I need the angle between that vector and the original a vector. That would be this angle. So I will use law of cosines again. I'll call this angle phi. So using law of cosines, with the cosine of the theta, cosine of the angle isolated, it's cosine of phi equals 5 squared plus 7.199 squared minus 9 squared over 2 times 5 times 7.199. Okay. And that turns out to be 0.0578 with the help of the calculator, and then inverse cosigning that gives me a phi value of 93.315. And so my drawing was okay. It looks about 90 degrees here. Okay, so to wrap up, remember when you're adding vectors to copy the vector, move it so that the tail of the vector you're adding to the original vector is on the head of the original vector. Copy it here, draw the new vector from the original tail to the new head, and then use law of cosines to find the part of the triangle that you need to find. And then for subtraction, remember that a minus b is the same as a plus negative b. And so copy the vector, but copy it backwards, so it's pointing in the other direction. Draw your resultant vector, set up law of cosines again, and do the same thing. Okay, hope that helps. Thanks for watching K109 Math, and we'll see you later.